Okay, I think this is ready. Medium today. Unfortunately, it's the same type of problems as the last few, which have been hit or miss in terms of success for me. Anyways, find the largest area of square inside two rectangles. Okay. There exists n rectangles 2D in a 2D plane with edges parallel to the x and y axes. You're given two 2D integer arrays, bottom left and top right, where has bottom left has A, B, and top right has C, D, representing the coordinates of the bottom left and top right of a rectangle, of the ith rectangle. So I guess they have to be the same. You need to find the maximum area of a square that fits inside the intersecting region of at least two rectangles. Okay, yeah, sure. The maximum area that can fit inside the intersecting region. So here, 1, 1 to 2, 1, 1 to 3, 3 is one rectangle, 2, 2 to 4, 4 is another rectangle, and 3, 1 to 6 is the last rectangle. I guess the intersecting one, you can do a 1 by 1 here, or even a 1 by 1 in this region here. A square with side length 1 can fit inside the intersecting region of square 0 and 1, or in the side regions of rectangle 0 and 1, rectangle 1, 2. Hence the maximum area is 1. This can be shown at this square. Okay, yeah. This is non-intersecting. No, it's 1, 1 to 5, 5, 1, 3 to 5, 7, 1, 5 to 5, 9. Maximum would be a 2 by 2. Maximum here might be a 1 by 1. No intersecting here. Okay. It's disgusting, but I'll try it. Oh my lord. What to do? I think this is something along the lines of whatever the hard problem was a couple of days ago, but like the hard problem had more than this. Intersections. The issue is if I sort by like x coordinates, it doesn't guarantee anything. Rectangles be rectangles. Intersections of rectangles. Oh. 1, 1 to 5, 5, 1, 3 to 5, 7. If I'm given those two rectangles, how would I find that their intersection is anything? How would I find that their intersections are anything? So 1, 1 to 1, 5 has an x range that is 1 to 5, a y range that's 1 to 5. 1, 3 to 5, 7 has an x range that's 1 to 5, and a y range that is 3 to 7. So I can maybe tell that they have to be intersecting in both the x range and the y range. I think. Could it be something where I use some sort of asymptotic stack? Not asymptotic, monotonic stack. Can I use a monotonic stack to do something? If I use a monotonic stack, push 1 onto the stack, push 5 onto the stack, 1, 5, 1, push a 1 onto the stack, push another 1 onto the stack, push another 1 onto the stack, 1, 1, 1 to 5, 5. If I convert the bottom left and convert the bottom left and top right to X range and Y range. Right, so something like, so the X range would be for the first rectangle 1, 1 to 5, and the Y range for the first rectangle is 1 to 5. The X range for the second rectangle would be 1 to 5. Second rectangle, the Y range is 3 to 7. Does that help at all? I think I have to sort. I think I have to sort by, how would I sort this actually? What am I going to do? What would I do here? How would I sort? I need to keep track of both things, kind of. I think I maybe make an array that is a like x min x max, y min y max, something like that, and then sort x min x max, y min y max. Let's say rectangles is going to be it'll have tuples of x min x max, y min y max for every rectangle in the bottom left, bottom right. So these arrays are equal, right? Yeah, they're the same length. Okay. N is equal to the length of, let's say, the bottom left array. For every index, I'll just say I in range. And rectangles append x min will be bottom left at this index, the first coordinate. And then X max is going to be top right at this index, the first coordinate, and then bottom y min is bottom left at this index, the first coordinate, second coordinate, top right index, second coordinate, rect sort, rect, rect, no, it should be rex, rect by the rex. Okay, so test case 1, 1 to 3, 1 to 3, 2 to 4, 2 to 4, 3 to 6, 1 to 6. Alright, looks fine. Okay, so how does that help me? Does that help me? What? Is that actually what I'm looking for? I think so, maybe. So if I somehow put these onto the stack, if somehow put these onto the stack, when I remove them off the stack because they're if I push them onto the stack, so if I push 1, 3 onto the stack, and then if the next rectangle overlaps with the previous rectangle, I just keep on pushing it into the stack. Is that what I want? Like I push 2, 4 onto the stack, and then I push 3, 6 onto the stack because it intersects with that. And then I would 3, 6, push, 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 push. Let's say there was another, let's say just a random square at 7, 8. At that point, I know that that square can't actually overlap with any of the prior rectangles. So then I can pop off the stack. How would popping off the stack work? So 3, 6 intersects with 2, 4, which is the next item on the stack. 3, 6 doesn't intersect with 1, 3. So every time it pops an interval off the stack, checks to see if it's intersecting with the previous interval on the stack. Does that work? Like, well, how would I check? How would I check multiple? 3, 6 intersects with 2, 4. Could intersect with like a could not intersect with something like the 2, 3, 2, 3. Then it could still intersect with something that is a 1, 1, 4. I think when I push onto the stack, it needs to push based on the y coordinate or the x max. Push onto a stack, sort. At that point, is it heap? heap. Oh my lord. I want to take off the stuff that has the highest X max rather than based on the sorting of the X mins. So the heap would clarify be something like X max of the range, and then what's secondary to that? Secondary to that might be Y min, Y max. Maybe it has an index as well to refer to where the rectangle is. I mean, it probably needs the information for X min somewhere. Frustrating. This is very frustrating. I don't think I ever learned this shit. Or never did problems that had this sort of overlapping stuff. Or whatever data structure or concept this programming concept that this uses, I don't think I ever encountered it with respect to problems like this. Or I could be wrong, just simply not thinking that good enough, well enough. Could just not be thinking about it well enough. It's quite possible. Each rectangle I encounter sorted. Like, what the hell's going on here? There's only 3 rectangles. 1, 1 to 3, 3, 1, 2 to 3, 4, 2, 2 to 4, 4. Just need to know the overlaps, right? The largest overlap. I wonder if I can do binary search here actually. Can I? Binary search for the value? No, I don't think I can. It's a precise value. It's not like I can guess. Maybe. Can I do binary search? Can I guess the correct answer and do a linear time check? I guess the answer is 4. Can I do a linear time check to see if 4 works? That is interesting. That is interesting. Linear time check. So I'm already sorting the rectangles. That's going to be n log n time. So binary search is not going to make that any slower. Can I do a linear time check for a certain value? Definitely do. If I'm guessing, let's say 4, right? Then I can ignore any rectangles that have area smaller than area whose side is smaller than the side length of the square that I'm looking for. So let's say instead of finding the maximum area, I'm just trying to find the maximum the side length of that side length of the square with maximum area that fits, right? So if I'm just dealing with side lengths, then I can skip over rectangles that have side lengths that are smaller than I can skip over rectangles whose x range or y range, their width or height, is smaller than that side length. That's easy. Very easy. And then I just need to somehow check. Just need to somehow check overlap somehow. Somehow. 1 to 3. Push 1 to 3 into the stack. 1, 3, and the next one is 2, 4. Could I just do a check then? If 2, 4 fails, do I know for sure that I can get rid of the 1, 3? I don't think I can, right? 2, 4 could technically, because 1, 3 could technically still work. Let's say there was, no, that's not true. So if it's 1, 3, if anything later than that has, based on the 3, let's say I'm searching for whether or not there's an overlap of 1, I guess. There's an overlap of 1. So the side length has to be 1, so any later rectangles I'm dealing with needs to have x min that is 3 minus 1. So it needs to start at 2 or higher, or 2 at most. You could start with 1, you could start with 2. So x min, so here the x max is 3. X max is 3. Am I doing heap or am I doing a... I guess I'm doing a heap that's an increasing sorted, right? Find a min heap. Because I want to remove stuff that's not possible from the front. So 3. Oh my golly. Oh my golly. Golly oxen free. Golly oxen free. What the hell is that? Oxen free? Ollie oxen free? Is that what I'm thinking? Ollie oxen free. Hide and seek game. All ye outs and free. Okay, anyways. Developing ADHD on the fly. Golly. What rhymes thoughts I'm free that's programming related. Golly, golly, code and shoot me. All right. My x max. When can I get rid of stuff in the heap? So I push into the heap x max, y min, y max. When I push onto the stack x max, I know that the rectangle that I'm dealing with has at least that length and has at least the width, x max, an x range that is what's necessary for the square that I'm trying to guess. So if some later rectangle has a x min that is equal to x max minus the side length that I'm testing, then that works for the overlapping x range. And then I just need to verify if the y range overlaps correctly. And if it doesn't, then what happens? If it doesn't, then I just push that onto the stack as well. Push that onto the stack as well. It's going to get hidden in the stack at that point. And then how would later things compare with that, I wonder? Not well is the answer. Later things just don't compare to it. Unless I have some better way of handling it. X. So 3. I see that there's a rectangle from 2 to 4. But let's say the rectangle from 2 to 4 actually screwed up, right? Let's say it's like 2, 4, but the height is 3, 4. So there's no overlap. In theory, there could be still another one that was like 2, 5, and the height was 2, 3, and therefore the overlap as well. Or maybe there's some, actually, I guess that actually works for this problem. Maybe there was like a 2, 3, a 2, 4 on the x and a 3, 4 on the y. And let's say there was another one that was a 2, 6 on the x and also 3, 4 on the y. Then at that point the heap is still having this 1, 3 rectangle at the top. So it doesn't compare the 2, 3, the second and third rectangles. To the third, 1,000. 1,000, 1,000 is a million. Yeah, so I mean, I'm thinking n squared is just going to be very slow. It might actually be within time, but this thing probably suggests n log n. Binary search might work still here, right? So binary search for 1,000 log 1,000. 1,000 log 1,000 would be log 1,000 is 3, right? So it'd be 3,000. All in the It's all in the theory. Execution's probably pretty simple. What is the theory here? 1, 3, 2, 4, 3, 6. Have overlapping. It needs to have at least an overlap of the size I'm considering on the x-axis. It needs to do this linear time. And if it has the overlap of the size I'm looking for on the x-axis, then it needs to then do some sort of just a quick check on the y overlap. Quick check on the y overlap. What if I just do 2 separate checks, right? I do 2 separate checks and have a matrix that's 1,000 by 1,000, so a million. It's not too bad, right? A million, like it's just a matrix. 1,000, so let's say a million ints to ints stored in Python. This is like 20 megabytes. Is that right? 20? 35 megabytes. Alright. Maybe I just need to do 2 separate things. Keep a matrix of indices. Keep a matrix of row and column indices that work. That's really not optimized. But maybe that's still fine. So for every index ij, interesting. Then I would still need to iterate over. Has to be linear, huh? Fuck. That's not linear time. Yeah, matrix of filling in the matrix of just which indices overlap with which indices. Well, is it? Is that gonna be quadratic? Can I make that linear somehow? So given x intervals, can I somehow create an array of x min, x max, x min, x max. One to three. So there's a 1 to 3, 1 to 5. Get quite close. 1, 3, 1, 4. Then you have your 2, 2, or let's say you have 1 to 3, 1 to 4, and then you have a 2, 4. And you say that the 1, 3 overlaps okay with the 1, 4 and the 2, 4. God damn it. 1, 3, 1, 4, 2, 4. I don't think it's linear actually. By which I mean I don't think. So like, the key question right now is, can I make a linear time algorithm that checks whether there exists an overlapping, let's say k length on or any kind of two rectangles, x ranges. So if the first rectangle is 1, 3, 2, the second rectangle is 2, 4, the third rectangle is 3, 6, and I guess that k is 2, can I somehow do a linear time check? One pass over all the x-min, x-max ranges of the rectangles to see whether or not k, that 2 length overlap exists somewhere between any two rectangles. Because if I can make a linear time algorithm that does that, then I can make a linear time algorithm that does the vertical, and then I can do some sort of check that actually I need to do a linear time algorithm that checks. Yeah, I can do linear. No. Let's do the exact same overlapping rectangles, right? Can I, and I guess this is also, and store it in some linear space, like array. If I can't store it in a linear space array, then that just doesn't work. I would have to store it in a square matrix. And a square matrix, to populate a square matrix, would just take, well, it's not linear time at that point. So this doesn't feel doable. Because I don't, in order for it to have a linear space storage of that solution, it needs to have some sort of underlying structure to the data, where you can say, for instance, like the rectangle index I works up to like +3 of that index, and the rectangle index I +1 works to +4 of that index or something. So there has to be some sort of shortcut in the data to make it linear. Shortcut in the data, shortcut in the calculation of where those two rectangles reside. Current 0 of a square does not such a square does not exist. 0, 0, 0, 0. 0, 0, 0, 0. Too many. Overlapping regions. Two, 2 to 4, 4. 1, 3, 1, 4. So if it's like 1, 3, 1, 4, but they're stacked on top of each other. So like there's a 1, 1 to 3, 3. Let's say there's a starting at 1, 3 to 4, 3. Like there's a bigger square stacked on top of this red square. So they're both going to be valid, kind of. 3 is the lower bound. 3 is the lower x max value. Then if there's another one that was like x value is 2, 3, then it should kind of come in front of the 1, 4 somehow, because the x max values is smaller than 4. God. I used to think I could do these. Irrational confidence. Irrational confidence on mediums anyways. Never really had any confidence in hards. What is rationality besides a fiction of the mind? Two, 4, 2, 4. 1, 3, 3, 3. 1, 1, 3, 3. Overlapping region. I mean, I feel like something like this is similar to stuff I've done with for meeting times and scheduling type problems, where when you schedule, you're dealing with meeting times, like you're dealing with a one-dimensional time, and you have a start and stop. You have a start and stop rate. But then normally those type of problems, like you're returning an answer just based on the maximum meeting time or something like that. You're not really storing an answer based on the indices of those meetings that you're working with, and that's kind of what you need to do to cross-check whether or not somehow those meeting times have a y dimension, and that y dimension needs to overlap as well. So how would I reformulate this into like a meeting? Each meeting has a meeting times, a start meeting time and end meeting time, and each meeting has a y dimension. Each meeting has there's like some sort of numbering of participants in the meetings, and participants are all kind of consecutive. So like the 1, 1 to 3, 3 means there's a meeting time from time 1 to time 3, and has people that are numbered 1 to 3 during that time. This is meeting time from 2 to 4, and uses people from number 2 to 4. I don't think that works actually. This should probably be 1, 2, 3 as kind of in between. So this first meeting takes person 1 and 2. The second meeting takes person 2 and 3. This next meeting takes from time 3 to 6 with person 1 through 5. Trying to find the square overlap of meeting times and number of people in both. The square of that or something. Ain't no sunshine. I wonder if I could do a square algorithm. I wonder if I could do a square algorithm. Or the square one work? The square one just seems so slow. It might solve it still. It's gonna be a very bad worst case in the square one. It's gonna be so damn slow. Parameters 1 times 10 to the 7. Like if it's all overlapping, then it's just so god awful. All overlaps and so god awful. One, 3. 1, 3. Skip. Testing if 3 works. 1, 3 doesn't. Two, 4 doesn't. 3, 6 possibly. 3, 6. There's nothing after that. So then chest 2 overlap. 1, 3 is 2. Next one has a starting X that doesn't work. And so I think we put that at that point. 3 doesn't work. Any later rectangles has the X max. We push onto it 2. Push onto it 4. The new X max. And then you see that there's a 3. That doesn't work with 4. Half the 4. Push onto it 6. What's the point of that? Jesus. Should I give a hint? Should I give up and do a hint? I guess the hint. I don't know. These mediums are just soul crushing. Okay, I will go ahead and do a hint. 1 hint for the road. Root force the intersection of each pair of rectangles. Are you serious? It is n squared? There's no brute force it. I mean, I guess sorting it is going to help the brute force. It's going to make it quicker. Oh my god, I just fucked this up. Okay, so if I do a brute force method, how would that work, right? Okay, so post hit 1, use brute force. Sure. For every index I is compared to index j, maybe stop when it no longer can possibly work. Right? So I'll use j and k for every index j in range, and for every index k in range j plus 1 to n. I'll just stop earlier if need be. Actually, I can't stop earlier. Right? Can I stop earlier? I can stop when the interval is too small. So that there's no overlap. So I think I just need to first calculate x overlap, and then if x overlap is equal to 0, then at that point I can continue. I can break, sorry, I can break. Sure, it's fine. I wonder if I should do something where yeah, so I need to calculate the x overlap. And then if I don't calculate, if I find that there is some x overlap, then I need to calculate the y overlap. And actually, my answer is going to currently just be side length of the largest overlapping square. We'll just return the answer squared, I think. And then once I calculate the y overlap, then I can just do like answer if the minimum of the x overlap and y overlap, if that minimum is bigger than the answer, then answer equals the minimum. I guess I should probably store that. And inside is going to be the minimum of x overlap, y overlap. And if this min side is greater than the answer, then the answer equals min side. That's the sketch of it. Now it's just a question of the logic. So let's say what's going on here? So I think this is going to be x max of the outer one is going to be, it's going to be the second thing in the rectangles at j index 1. It's always sorted by x min, so I don't really need to worry about that. X min will always be bigger. So yes, this x overlap is just, if x overlap is, I guess, less than or equal to 0, x over left should be equal to the x max minus the rectangles of this k, the second rectangle at 0, which is the starting x for it. Yeah, that should be the x overlap, right? So it's be 3 minus 2, 3 being the x max of the first rectangle, 2 being the x min of the second rectangle. And then calculate the y overlap. So here, what's the logic here? So this 3 has to be greater than this 2. This 3 has to be greater than this 2. Or this 2 has to be between 1 and this 3. This 2 has to be between 1 and 3. And 4. I guess the whole thing resides in this 2 being between 1 and 3. The y coordinate 2. So calculate the y overlap. If the y, guess I should probably just do x min, x max. Yeah, just pull it out. X min, x max, y min, y max. Technically, I could probably do an underscore instead of x min, so I can't use that. So if the rectangles at k, the y min of it, which is the next 2, is between y min and y max. Then the overlap will be whichever the difference between this, distance between this and the minimum of the y min and the other y min. Y overlap equals the minimum of y min and the rectangles at k at 3 minus y minus rectangles at k at 2. I wonder if I can do something. I guess this needs to all be in this if statement. I wonder if I can do some logic that gates this so it doesn't have to be this. My head is a little slow at the moment. Head, brain, a little slow this year. I mean, this is brute forcing it for sure. If there is no y over, there's no x overlap, then any later one wouldn't work either, right? Any later one wouldn't work. I guess I can also do if the x overlap is smaller than the answer instead here, because if it's because at that point it can't actually improve the answer. F, 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 F. What is going on? This thing returning 6. Excellent. Returning 0. I can do that for sure. min side is greater than answer, answer equals min side. For every j index and for every k index, j plus 1. Okay, let's go ahead and just print this out. Ain't no sunshine. It should do it right on it. It should get the answer equal 1 at the very first pass. So let's say here print jk x overlap. So rectangle 0 to rectangle 1. X overlap is 1, which is correct. X 0 to 3, X overlap is 0, that's correct. And then 1, rectangle 1 to rectangle 2, X overlap is 1, that's correct. So calculating X overlap correctly. Then it's this logic here. Rectangles at K at 2, which is the bottom, the Y min. If it's between that and if the other rectangle's minimum y coordinate is between the y min and y max. Okay, I guess I just need that here. This is probably confused. Hopefully it still prints out. Okay, it does print out. Y overlap is -1. The logic is wrong here. The minimum. Yeah, it's supposed to be y maxes, so y max. It's the smaller of the two y maxes, so y max. Okay, yeah. Okay. Movements. Okay. Didn't really go very far. 195 out of 661. Looks like a pretty simple one. 2, 2, 1, 3, 3, 4, 5, 5. Let's go and print out the rectangles. Maybe X overlaps. It's not going to be 1. Okay, so it's going from 1, 5, 1, 5, 3, 5, 1, 5, 3, 5, 2, 3, 2, 4. Okay. So 0, 1, the X overlap from 1 to 3, 1 to 5 versus 2 to 3. Oh my god. My logic, that's horrible. Overlap should be 1. It's so bad. X max. Yeah, so it should be X max minus rectangles at K, 0. That's so wrong. Should be the minimum, just like I had the Y max compared with the rectangles at K3. It's the minimum of this and rectangles at K1. So bad. Okay, so it has the correct X overlap. And now, why is the y overlap not correct? So it doesn't even get to the y overlap stage. So y overlap should be if the lower y coordinate is between x min, y min and y max, so it should be between 3 and 5. And here the lower one is 2. Yeah, so it doesn't need to be between them. Okay, I'm so bad. So if it's either 2 or 4 is between 3 or 5. Yeah. Oh my god. So bad. 2, 4, 3, 5. I was assuming that the first y was actually smaller than the other y, which is just a bad assumption. 3, 5, 2, 4. How to find just generically which one is which? 3, 5, 2, 4. 2, 4, 3, 5. So if the y min is between, I guess I can just do the reverse logic. I can do something like else. Would else here work? Else if rectangles at k 2 less than equal to y min less than equal to rectangles at k 3 y overlap equals min y max rectangles at k 3 minus y min inside equals min of x overlap y overlap. If inside is greater than answer equals inside. Okay. Went through all the cases inside. Okay. Right. See if this works for more cases. It should. Disgusting. Okay. Sure. So it should be like 2 to 24, yeah, 3 to 19, 15 to 30, 22 to 25, 24 to 41, sure. So testing this rectangle versus this rectangle. 16, 2 to 24, 3 to 19. 3 to 19 is within the interval of 2 to 24, so it's going to be 16 is the x overlap. Okay. And there was no y overlap. 1, 2 to 17, 27. That's not y overlap, sure. This compared to this, the x overlap should be 15 to 24, which is 9. And the y overlap should be 0. Okay, this thing compared to this thing, X overlap should be 22, 24, so that should be 2. Y overlap again is 0. 24 to 24, 0 overlap. 0 X overlap. And then it goes on to this thing compared to this thing. 15 to 19 is the X overlap, so that should be 4. 17 to 27 versus 20 to 29. Overlap should be 20 to 27. That should be 7 overlap. So the min there should be 4. Okay. Answer was 5 somehow. Anyways, 3, 19, 3, 19, 15, 30. Okay, so this one compared to this one, there's no X overlap at all. This one compared to this one, again, there's no X overlap. And then here, actually, it didn't do that one because it knew that if this one didn't work, then it didn't compare this next rectangle. So then it goes on to compare these two. So overlap on the X should be 3. Overlap on the Y. Overlap on X is 3, so it doesn't compare it anymore. This one compared to this one. Overlap on the X should be 6. Didn't compare 2 to 3. Didn't compare 2 to 4. It should have compared 2 to 4. So it was skipping it too early. If the X overlap is less than the answer, break. Give me a break. I see. Yeah, I see. If the X overlap, I think the logic here is just wrong for when I should skip. So I should skip if the rectangles at K, the starting X coordinate of it, which is at 0, is greater than or equal to the rectangles greater than or equal to X max. Continue. Okay, I think that's the only time I should skip because there's other logic here that doesn't break. But if it is less than the answer, then continue. Okay, I didn't have the correct test cases in my mind. So I obviously made some logic errors there. Nasty, nasty, nasty. Nasty garbage code. That's disgusting. So disgusting. I mean, I guess like some of these things are just strictly using brute force. Every single combination of rectangles, there is something to be optimized for this. Alright. Yeah, there was some slight optimization for the sorting, but So I'll say here for the summary. So relied on the hint to direct me to use a brute force method, which would take O of n squared time to compare every combination of rectangles. Did that with some optimizations, basically shortcutting, sorting rectangles, and short circuit exiting, short circuit breaking the inner for loop to cut down the number of impossible kind of overlaps. Impossible with no overlap or with no improvement on the current answer. So general steps is one, I'm not sure if this was needed, but I converted to a single array of tuples where it's the xmin, xmax, ymin, ymax for every rectangle. And sorted, that's just pretty straightforward. Like iterate over the indices, append to whatever array that you're making the tuples sort, and then use nested for loop to brute force comparisons between every index. I use j and later index k. And determining the overlapping kind of side length for both x and y ranges of those rectangles. Used a lot of logic to cover the various cases, and also did a check to skip if the kind of x max 1 of the outer rectangle of the k rectangle is skip rest of comparisons. If x max 1 of the k rectangle is smaller than the x min 2, so x min of the x max of the j rectangle is smaller than x min of the k rectangle. Since all later k rectangles would have an even higher x min. And then again, after I find the overlap, then I just return the area of the square based on the overlapping side length. Okay. So I'm not inclined to go over this logic again, but hopefully it's somewhat understandable. I don't know. Time complexity is going to be O of n squared to do every j and k comparisons of rectangles. The initial creation of rectangle tuples that are sorted is O of n log n. So it's faster than the rest of the algorithm. So it shouldn't really matter since I'm already being slow with that. Space complexity is going to be O of n to create the